Hello students, in this video what I will do is I will go through the solutions to exercise U4A02B rather than going through it live with you guys, just because it will require a lot of writing on my part and the video will just end up being like 40 minutes long like the last video, and I don't want the video to be like overly long. So I already have all the solutions written out, so I'm just going to sort of summarize and explain my thoughts and why I came to those conclusions. So for question letter 1A, you have to explain whether or not the information or the diagram presented is in fact a parallelogram or not. And yes, this most definitely is, because this is just reading directly off of the properties of a parallelogram, that opposite sides are congruent. Quadrilateral B, opposite sides are parallel. So yes, most definitely, this is in fact a parallelogram because opposite sides are parallel. Quadrilateral C, the diagonals are bisecting one another. So yes, most definitely, this is a parallelogram. D is where things begin to get a little more interesting. So the diagonals intersect one another, and what ends up happening is we end up with the diagonals forming two pairs of vertical angles, all of which are congruent to one another. And what that implies is then we end up with 90, 90, and 90, right? Since all of them are the same. This is not a parallelogram. Please convince yourself of this. Not only because it doesn't really look like or pan out to be one of the properties that we had discussed, but also because the quadrilateral can end up looking like something like this, and doesn't necessarily have to be a parallelogram. Here the diagonals, they intersect and they form all 90-degree angles, but based on that drawing there, that's definitely not a parallelogram. I want you to feel in your bones like why certain quadrilaterals are parallelograms and certain quadrilaterals are not. And the way in which you do that is, like, you have to internalize the properties, and not only internalize the properties, not only being able to list off what those properties are, but also just to like really feel for them, okay? And it's kind of funny for me to say like feel the property, but in the long run, after you've internalized something, yes, you are. It's like a musician, like, when they're playing the instrument, they're not only practicing their skill, but they're also feeling the instrument, and they're feeling, what they are doing. So anyway, question letter E. We have opposite angles are congruent. So yes, this most definitely is a parallelogram because this is just reading directly off of the properties list. Here we have segments within the quadrilateral that are bisecting one another, and don't be fooled by this. Right? These are not diagonals. The lines that I'm drawing right now, those are diagonals. And if those lines in red were bisecting one another, then we can say for sure that this would be that would be a parallelogram. But because of this, we don't really know for sure. If anything, what could have happened is, something like this could have been drawn. Hold on. So something like this. Where just some random segment where these are the same and these are the same, right? So you can see what I mean by that now. Even though like what I'm doing here in red is like an exaggerated version of F, I mean, that's theoretically what could have been, right? Okay, so moving on. Question letter G. So here in this case, this is definitely a parallelogram, and it does require a little bit of explaining. Since these are congruent and all of these are congruent, so that means this angle over here, like the total angle is 2x, the total angle over here is 2x. So therefore opposite angles are congruent. If these are y apiece, that means this is 2y and that is 2y. right? So opposite angles are indeed congruent. So yes, we can say that this is a parallelogram because we're adding the angles together using the angle addition postulate. Okay, moving on. Question letter H. Diagonals are bisecting one another. So yes, this most definitely is a parallelogram. Opposite angles are congruent to one another. So yes, this most definitely is a parallelogram. Opposite sides are congruent. Most definitely is a parallelogram. Here for letter K, we can't really say that this is a parallelogram, not only because it doesn't fall into any of the properties, but we could have also drawn the this quadrilateral to look like this. So imagine that these two sides are parallel, right? And then these two sides over here are congruent. That clearly is not a parallelogram. That in fact is an isosceles trapezoid. Okay? All right, and then for question number 2, I graphed out the quadrilateral ABCD, and the computation really just speaks for itself. We find out what the midpoint is. The midpoint turns out to be 0,2, and the computation can be seen over here, right? So once we find a midpoint, we can then declare, yes, this ABCD is in fact a parallelogram because the diagonals here, they bisect one another. Okay, both of them, they actually share the same midpoint. And this guy over here, WXYZ, is a parallelogram because opposite sides have the same slope. So opposite sides are parallel. So again, find out what the slope is by using the slope formula. Okay. Here we can show that quadrilateral PQRS is a parallelogram using the property that opposite sides are congruent by applying the distance formula. But like I've said in multiple instances, you don't need to apply the distance formula verbatim. You can also just apply the Pythagorean theorem as well. And a lot of times it is way more convenient to apply the Pythagorean theorem over the distance formula just for the just the amount of things that we have to take into consideration, like square roots and squaring things. It is a lot more convenient to write things using the Pythagorean theorem rather than the distance formula. And that's pretty much it. So yeah.